In this module, let us understand the phenomenon of heat transfer. Heat is energy transfer from one system to another or from one part of a system to another, arising due to temperature difference. This heat transfer takes place by three modes: conduction, convection, and radiation. Let us first study about conduction. Conduction. Conduction is the process of heat transfer between two adjacent parts of a body or adjacent bodies due to their temperature difference. You must have noticed that if you heat a rod by applying heat at one end, then the other end also becomes hot. The other end becomes hot due to the heat transfer by the process of conduction. It is important to note that gases are poor thermal conductors, while liquids have conductivities intermediate between solids and gases. Heat conduction may be defined quantitatively as time rate of heat flow in a material for a given temperature difference. Let us consider a metallic bar of length L, cross-section whose ends are maintained at Tc and Td degrees Celsius. Here we assume that the system is isolated from the surrounding. After some time, a steady state is reached when the rate at which heat is supplied at one end becomes equal to the rate at which the heat is transferred to the other end. It can be shown experimentally that the rate of flow of heat H is proportional to the temperature difference and area of cross-section and is inversely proportional to length L. Mathematically, H equals into A into Tc minus Td divided by L. The constant of proportionality, K, is called the thermal conductivity of the material. The ability of a material to conduct heat increases as the value of K increases. The SI unit of K is watt per meter per Kelvin. The thermal conductivities of some substances are shown here. Although these values vary slightly with temperature, they can be considered to be constant over a normal temperature range. You must have seen that some cooking pots have copper coating at the bottom. This is due to the fact that conductivity of copper is very high, as we can see from the table. It can also be noticed that the thermal conductivities of wood and plastics are very low. That is why they are poor conductors of heat and are used as insulators. The principle of heat conductivity is used many times in our daily life. For example, people prefer a layer of earth or foam on their ceilings as it prevents the heating of rooms. Also, heat transfer systems are very important in nuclear reactors, as a high amount of heat is generated in these systems.